Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to write formulas for monoatomic ions. Let's get into this. So in my previous video I showed you how to go from the formula or to the name for a monoatomic ion, but now here we're going to go in the reverse direction. Here we're given the name and we want to write the formula. We want to write the ion itself with the charge, and so that's what we're going to do. So here they give us the name, so we're going to translate the name into the formula. In this case, it seems to be probably a little bit easier to do that. So here, starting with phosphide ion, remember if it has an IDE ending and we know it's a monoatomic ion, then it means that that's going to be a negative ion. So that means we're going to have to write the name of the element. So from phosphide, the element's name is going to be phosphorus, right? So phosphorus is written, so phosphorus, so that's the name of the element from which the name phosphide came from. And so now we need to know the charge. So the charge is going to be, well, we put symbol first. So let's put the symbol here. So P for phosphorus. And so you need to be able to identify the charge from your periodic table. So there's a couple ways to do this. You can memorize what group it's in and memorize what the charge is for elements that are typical in that group, right? So you can remember, oh, it's phosphorus is in group 3, or I'm sorry, group 5. So therefore, it's going to have a -3 charge. Or if it's in group 6, it's going to have a -2 charge. If it's in group 7, it'll have a -1 charge. Remember, the rule for identifying the charges in groups 5 through 8 is the group number -8. That's going to give you the negative charge. Or you can remember that all elements want to be like the noble gases. So if you are in group 5, then you want to have a full outer shell, and the easiest way to, sorry about that. So the easiest way to be like a noble gas is to either gain or lose electrons. To get the noble gas configuration like the noble gas that is closest to your element. So for phosphorus, the closest element is going to be neon, right? Or not neon. I'm sorry. Let me get my, is it argon? Sorry. So argon. So in order to be like argon, argon has a full outer shell with 8. This has a valence electrons of 5 valence electrons. So to get the 8, it would gain 3. So, or it could lose 5, but it'll be a lot harder to lose 5 electrons. So it's easier to gain 3. So that's why if it gains 3 more electrons, it would have a 3 minus charge. So 3 minus. So that is the formula for phosphide ion. For B, we have the lithium ion. So in this case, we don't have the IDE ending, so that indicates that we have a positive ion, a metal. And so if we look up lithium on the periodic table, we find that it's in group 1. So again, if you know the rules for positive ions in groups 1, 2, and 3, then you would know that, oh, the charge on the ion is equal to the group number, right? So the positive 1 charge would correspond to group number 1. If you're in group number 2, that would correspond to a 2+ charge. Group number 3, that would correspond to a 3+ charge. Or once again, the better way is to understand that these charges are coming from gaining or losing electrons. In this case, it's a metal, so it's going to lose electrons to be like the noble gas. So for lithium, it's in group 1, so it can lose 1 electron to be like a helium, right? So helium is the closest noble gas to lithium, And so to be like helium, it just needs to lose that one electron. Another possibility, it could gain 7 more electrons, but that's highly unlikely and harder to do. So lithium is going to be more like its closest noble gas. So lithium would lose 1 electron, and therefore it has a +1 charge. So the formula would be the lithium symbol with a plus charge on it. So that would be the formula for the lithium ion. Next, we have cobalt-2 ion. So cobalt, notice there's no IDE ending, so this is a positive ion. It's a metal. This is one of the transition elements. So we have a Roman numeral. So we're going to write the symbol for cobalt. And in the Roman numeral, remember the Roman numeral tells us the charge on the positive, on the metal ion. So that would mean that this has a 2+ charge. Next, we have the bromide ion. Notice we have the IDE ending. And so that indicates that we have a negative ion. And so we're going to have to write the formula or the symbol for this element, which is bromine. So bromine is the element. We're going to write the symbol Br. And since we know where it is on the periodic table, we can figure out what charge is going to be. It's a main group element or a representative element, which means it's going to only have that one charge. And so we look on the periodic table and we see bromine is in group 7. So either you know the rule, which is the group number -8. So 7 minus 8 is -1. So it has a -1 charge. Or you can remember that, oh, it's in group 7. It wants to gain 1 more electron to be like the closest noble gas. So it's going to have a -1 charge. So we put a negative. And so there's our formula for the bromide ion. Next, we have aluminum ion, or for our friends across the lake, it would be aluminium. I can't even say it. It's hard to pronounce. Aluminium ion. So here, again, we have aluminum. Aluminum is the metal, so it's not, there's no IDE ending here. So that means it's a positive ion, it's a metal. So we're just going to write down the formula or symbol for the element. That's going to be Al. And then finally, what charge is the aluminum ion going to have? Well, again, you can look at the periodic table and say, oh, it's in group 3. So the rule there is if you're in groups 1, 2, and 3, then the group number is equal to the charge. So the charge is equal to the group number. Aluminum is in group 3, so therefore it's a 3+ charge. Or the other way you can think about it is it can lose 3 electrons to be like the closest noble gas. Losing 3 negative electrons means that you're going to have 3 protons extra compared to the electrons, so you get a 3+ charge. Okay, finally we have gold-1 ion. The gold-1 ion, again, gold is a transition element. It's a transition metal. The 1 in the parentheses, the Roman numerals, tells us to charge on it. This is, again, a transition element. And so we would expect a Roman numeral. Remember, there are those exceptions: silver, zinc, cadmium. So we're going to write the symbol for gold. And the Roman numeral tells us the charge, which is a 1. So we're just going to put a plus. And that, ladies and gentlemen, is how you come up with the right formula for your ion's name. This is for monatomic ions. And again, if you like this video, then please like, share, and subscribe to my channel. Make sure that when you do, you click that button or the bell, the notification bell, so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If you want me to do a topic or want me to answer a question or go over a problem, I would love to do that for you. Thanks for joining me and have a great day.